Now that we're familiar with addressing and getting data from one computer to the next, we have another challenge. How does the computer that's receiving those communications know where that data goes? In this perspective, which application should or should not receive the data that was sent to that system? This is where ports come into play. Ports are logical identifiers that are registered and associated to processes or services running on that computer. Essentially what happens is when an application starts, it communicates to the operating system and attempts to reserve an available port. If the port is available, it is now assigned to that application. Thus, any communication that is going from or to that port will be sent to the appropriate application. If an application attempting to start is trying to register a port that is already in use, it will receive an error that it cannot use that application port. Sometimes this might be detrimental to an application starting. If we wanted to instantiate a web server on a Linux computer and a port was already being in use, say port 80, which is the standard HTTP port, the new web service that is trying to start could not fully initialize and load, thus throwing us an error that it can't work as intended. But most important of all, ports allow for multiplexing of communications. And what this simply means is we can have multiple services and applications running on a host, and they each have their own registered port that they're using on that interface. Thus, when we send data to one IP address, we can actually talk to any number of applications using one address. If ports didn't exist, we would only be able to send data to one application with one IP. And that simply wouldn't work with how many applications we use day in and day out that require network communications. So let's talk a little bit more about what ports look like. They are a logical identifier that's usually identified by a sequence of numbers, and that number ranges 0 through 65,535. Just as we had classes or ranges with IP version 4 addressing, we have the same concept here with ports. The first being the well-known port range. This is any port that is between 0 and 1023. We then have registered ports with 1024 through 49,151. And finally, we have ephemeral ports, 49,152 through 65,535. So again, when an application registers and uses a port on the network interface, what also is happening is there's an expectation that a certain application or protocol will be used. So we had previously mentioned port 80 being associated to web servers. Well, web servers use the HTTP protocol. So whenever we see port 80, there is an assumption that it is the HTTP protocol that is being used in the content of that communication. So the well-known port 80 is metadata. It is a characteristic that describes that information, that flow of communication. But if we actually look into the content, what is being sent, we should expect to see HTTP. The Internet Assigned Numbers Authority, or IANA, are responsible for setting the standard ranges for port categories, and they are the organization that you would go to if you would like to register, which means you pay for a port association. So there are many private entities, businesses, Microsoft, Oracle, a lot of these companies build databases and applications and proprietary products, and they want their own distinct port associated with their product. So that way, when you're doing network-based communications and you're installing a specific proprietary product, everybody knows that we're going to use that port to talk to that associated service. And then again, ephemeral ports. Ephemeral ports are primarily used as client, and ephemeral means dynamic or changing. They don't associate to any one application. They're used by clients to establish communications to a server. We need ports on both sides of the communication. We would connect to a well-known port, but we also need an ephemeral port so that well-known service can talk back to us. Because remember, we have an application on the client side, say our browser, Chrome, needs a port so that it could talk out over the internet. So it's given an ephemeral port to use as a client port, and your computer then uses that client port to then talk to the well-known service, port 80, to get to the web server. So to make a little more sense of that, let's look at the client-to-server model, or it could be referred to as the server-to-client model, depending on how you look at the flow of communications. We use the direction or flow of data towards the well-known port to determine which device is the client and which is the server. So in this example, we've labeled it so we pretty much know which one is the workstation client versus the web server. But let's look at the flow of communications. We can see we have a client request on the left, and the flow designated by the arrows is going to the right towards that web server. But the destination port where the traffic is intended to go is port 80. So we would characterize this as saying the client is sending a port 80 request. It's establishing a connection to a well-known port. So we now know anything going towards a well-known port is the server. Where that traffic came from is the client. And if we look at the server response, we see that the destination port is an ephemeral port. It's a high-ordered random number. Only clients, for the most part. There are some cases where some protocols use ephemeral ports on both sides, but that's outside the scope of what we're talking about now. But in this case, the communication is going to a well-known ephemeral port, which we assume to be a client. So by knowing which way we're going to the well-known port, that's client to server. And when we have the server going to an ephemeral port, that's server to client. So by knowing the flow of communications between these two, we can identify which packet was originated from which source. Was it client or was it server? And generally, what type of request may be being made. When we look at HTTP traffic, computers always make GET requests for content in the HTTP protocol, and the server responds. So knowing just a little bit about how the internet works, we could assume a GET request is smaller. I want google.com. Well, it has to return the whole web page to the client, and that's a lot of data. So a server response over web traffic would be larger. So that's why it's important to understand the flow of communications, because it helps us characterize what we would expect to see in this communications when we're analyzing. So like any industry or area of study, there's just some things we have to remember, and ports are one of those pieces of knowledge that you just gotta know. There are way too many to remember all of them. This list consists of the more common protocols that one would be expected to know or remember. And just like history class, we've got to remember those dates to the wars or big events in history. And it just boils down to the fact that if you don't know these ports, people will start to question your level of knowledge when it comes to network-based communications and your ability to analyze traffic. So just memorizing these ports and knowing what they're at least associated to will get you much further than saying, I don't know in some cases. And this is just down to it, fundamental knowledge you should have that people will expect. So the first port is port 20, which belongs to the file transfer protocol. File transfer protocol is used to do file uploads and downloads. It's a legacy protocol, and it's not used as much as it was in the early days of the internet, but you will still find FTP servers out there where people are using them still to upload and download data. We then have the FTP port 21. This is the actual data channel that's used for sending the data. What's interesting about FTP, it's the only protocol that uses two distinct ports for both sides of its protocol use. It has port 20 for managing the FTP session and port 21 for actually sending data. No other protocol works over two ports like FTP does. Next, we have port 22 secure shell. This allows us to have a remote terminal on a host using encryption. It's an encrypted remote shell. It's much newer than the port and service below it, Telnet. Telnet is an insecure remote terminal service that has been around since the early days of the internet. It is considered insecure, and just generally it's a bad business practice to use this on production systems and have it available and running in a modern network. So if you ever see Telnet, probably should just turn it off. Next, we have SMTP, or their Simple Mail Transfer Protocol. It's the protocol that's used to relay email messages over the internet. Another very important protocol, and this is one you should definitely remember. Above all the other ones we really covered, this is a big one. Port 53, DNS, the domain name system. It is the service that allows us to do domain to IP lookup services. When you're using your browser and you type google.com, the DNS system will then take your request, your logical request that you typed, and then correlate that to an IP address so routers can transfer that request to the appropriate server based on its returned IP address that we received from that DNS lookup. Port 67 is the DHCP, or Dynamic Host Configuration Protocol. When your computer is added to a network for the first time, it does a DHCP broadcast in which a DHCP server will respond, and this is where your computer is assigned or given an IP address. This is a core service that is critical to the integrity of your network. If your DHCP service is not running or available, new clients or clients that are getting reassigned IPs will not get those IP addresses and thus cannot communicate over the networked layer of your network, and thus cannot communicate via IP across your network or over the internet. Port 80, the Hypertext Transfer Protocol, is a protocol that's used to view and access web-based content. It is the primary protocol we use every day when we access websites. Then we have Port 110, the Post Office Protocol. This is the protocol that's used by your mail client to download email messages from your nearest mail server, usually a mail server that's residing within your organization or hosted in the cloud for your organization. Next, we have port 443. This is the standard port used for HTTP Secure or HTTPS. Essentially, it's HTTP with a transport layer security payload that essentially encrypts the HTTP requests and response. So this is how we've taken a clear text HTTP protocol that didn't have security in mind, and we've now added a layer of encryption and privacy on that traditionally insecure protocol so that we can have secure web-based communications, so we can access our bank accounts and do various things of that nature